Good morning, and today we'll be looking at the context of differentiation, which is the rate of change. Now we can look at a variety of different rates of change. The rate of change of a function f dash of x can be evaluated for any value of x. When asked to find the rate of change, you need to recognise that that is asking you to differentiate the function. Okay, so it can be asked in this context, given f of x is equal to x to the power of 5, find not just f dashed of x, but f dashed of 2. So f dashed of x at the point x equals 2, that's what that means. So we're going to start off with the function of x, and then find f dashed of x, multiply by your power, take 1 off your power, and then replace the x in the bracket with the number 2 as given in the question. So you obviously replace the x on the right hand side with the number 2 as well. So f dashed of 2 is therefore going to be equal to 5 times 2 to the power of 4. So f dashed of 2 is, and 2 to the power of 4 is 16. So we're doing 5 times 16, which is 80. So f dashed of 2 is 80. So here's one where you're asked with words here, find the rate of change. So that other one was a more obvious differentiation question, but this one isn't unless you recognise and have the trigger that rate of change means differentiation. So as soon as you see that there's a rate of change question, it might not mention differentiation specifically, you have to recognise that that has the trigger to differentiation. Okay, you need to know that. That's what can make the higher questions difficult sometimes, not recognising what the question is asking. So find the rate of change of f of x equals 1 over x squared at x equals 3. So you know from that then, rate of change means to differentiate. So I'm going to differentiate the function and put x equals 3 into the differentiated function. So that's important that you know all of that. Now we had to fix up f of x. It wasn't in the form x to the power of n. So we had to bring the x up to the top and make it x to the power negative 2. We then are now ready to differentiate. So we do f dashed of x equals, so the multiplier is going to be negative 2. And the power is going to be negative 2 take away 1, which is negative 3. And that's fine if you're just asked to differentiate, but we are asked to substitute x equals 3 into this. Now, what is 3 to the power negative 3? We can't visualise that. So we have to bring the x down to the bottom so we can substitute the number in. So we change it at this stage, which is negative 2 over x cubed. Because now we can put 3 into that denominator and work out what 3 to the power 3 is. So f dashed of 3 is negative 2 over 3 cubed. And 3 cubed is 3 times 3 times 3, which is 27. So it's negative 2 over 27. So the rate of change at x equals 3 is the answer, negative 2 over 27. And you can leave it like that, because it can't simplify any further. Find the gradient of the tangent to the curve f of x equals x squared at x equals 4. Now, you may be asked the rate of change, as you were in the last question, or a very specific rate of change, which is the gradient. The gradient is the very common rate of change that we deal with. It's the rate of change of the y's over the x's, isn't it? So we need to recognise that the gradient of the tangent to the curve is a differentiation question. So this is how you're going to find the exact gradient at x equals 4 for this quadratic here. So we start with f of x equals x squared. We're going to differentiate it, making it 2x to the power of 1, which is just 2x. And then we're going to substitute x equals 4 into that. So putting x equals 4 in is 2 times 4. So the actual gradient at that specific point at x equals 4 is actually 8. So it's allowing you to work out the gradient at specific points on curves. And that's one of the huge advantages to differentiation. Okay, if that graph was the graph of distance against time, then that would be an instantaneous speed that we would have just worked out. Okay, Answer the question. If I say what's the gradient of the tangent to the curve and you say to me f dash of 4 is equal to 8, if I wasn't a maths teacher, I would say, what do you mean? What does f dash of 4 equals 8 mean? You would say, oh, the gradient of the tangent is 8. That would be answering the question using the wording of the question. So try to answer the question back into the context of the question again, okay? Right, so here we have a more complicated context question. Smoke from a chimney travels route t kilometres in t hours. Calculate the speed, reminding you that that's just a rate of change of the smoke after 9 hours. We give you tell you directly that the first sentence, smoke from a chimney travels route t kilometres, means that the distance travelled by the smoke is route t. So we'll make a little formula there that the distance of t is route t. Okay, so if they're telling you that speed is just the rate of change, then this is just a differentiation question. So it's a more complicated context, but it is just a differentiation question. Okay, now this is what this looks like. Don't copy the graph. You wouldn't even necessarily have the graph, but it's just showing you what this journey of the smoke looks like, the distance against the time. Okay, and we know that the speed is a rate of change, which is the gradient of the curve. And we're looking at that particular speed there at time equals 9 hours. Okay. So what we're going to do for this then is start with d of t equals root t, fix it up so it's t to the power of a half, differentiate it, so it's a half t to the power negative a half, multiply with the power, take one off your power, to get that power of negative a half, you've done 1 half, take away 2 halves. And then because we are substituting a number into this, we have to bring the t back down to the bottom and make it on the bottom line t to the power positive a half. But also 9 to the power of a half, we're going to have to put that 9 in there. We're going to have to bring it back to a third. So we're going to have to remember that that t to the power positive a half is actually root t. So that's 1 over 2 times root t. Now that we've got it back in that format, we can now easily work out what d dashed of 9 is. So at 9 hours, t is equal to 9, so we're doing d dashed of 9, which is 1 over 2 times root 9. Root 9 is 3, 2 times 3 is 6. So we've got 1/6 kilometres per hour using your 2 units that we had in the question, and that's what your speed would be. Now the question says calculate the speed of the smoke after 9 hours, so we just finish that off with saying that the speed of the smoke after 9 hours is 1/6 kilometres per hour. Now I haven't got it on this, I'm going to add it to it right now, but can we finish that off back in the context of the question? Speed equals 1/6 kilometres per hour. Speed equals 1/6 kilometres per hour. Okay, just back into the context of the question there. Okay. Right, so we're now on to exercise 6E, questions 1 to 6. Pay attention to the context of the question because this is where you're being introduced to these contexts. You have to recognise these types of questions in an exam where it doesn't highlight that it's a differentiation question. So pay particular attention to the wording. Ask your teacher if you need any help, and as always, take care and good luck.